I used R1, R2, R3, right? What are those representing? Remember, we you use that to denote what kind of specific row operation we did, right? So what could be a word that describe this RK or R2 is row 2. That's good. It's a better word than row 2, more specific than row 2, right? R2 is better. Isn't that an equation? Right? We call this entire second equation R2, right? So is that okay if I say it's an equation? Right? It has left hand side, it has right hand side, it's equal symbol. So we recognize an equation, it's not a number, right? It's not a function, is it? Equation is just an equation, not a number, not a function. But we've been using this notation like this, and no one asked any question. Everybody understood what I mean by R1 plus R2, right? But R1 is not a number, R2 is not a function. Have you ever added anything that is not a function or numbers? That's an example, and you understood it, right? And also I wrote 3 times R1. No one asked any question about 3 times R1. Everybody understood what this thing is, right? So we understand this equation, new entity in mathematics, very formal object. It's very difficult if you have to deliver this idea in, first and second or third year elementary school. Difficult. They're still in the world of numbers. Once you learn functions and variable, you accept this equation as a new mathematical entity. And then now you're able to add those two equations and multiply scalar, right? It's a new entity. This comes with a natural structure of addition and subtraction, and we call scalar multiplication. These things are called abstract vectors. So linear algebra is basically study of vectors in abstract form. So R1 is now called an abstract vector, an equation, but it has more fancier name, right? So it's the same thing. Now if you look at the matrices, each of the rows, right? What kind of thing is this? If you look at this matrix, this makes sense. You've been educated with this one for a long time. Now you're entering this one, right? It's a bunch of number. Slight difficulty to accept this as a mathematical entity, right? Let me write that. First, we're going to write this guy here as R1 once again. So what is R1 this time? R1 is not an equation, right? What is R1? Is it 1, 2, 3, 4? 4 numbers in order, right? So we accept that as a new mathematical entity. Now, if this is R2, everybody understand what I mean by R1 plus R2, right? You came up with a new row by adding those individual entries, right? So you accept this row as a new mathematical entity. What is a fancy name for that? V word, right? It's called vector. Vector. Yeah, if you can add and scale and multiply, this is called in mathematics vector. It doesn't matter in what shape it is. It's an abstract form of vector. Okay? Later, they call this whole thing as a vector. The whole matrix is also a vector. So you will learn that how to add to matrices, how to multiply scalar to matrices, and an obvious extension we can do that. So we accept this entire bunch of rows as one mathematical entity. Matrix is also a vector. Okay? So it's not just vector you learn in physics, in mathematics. It's became more abstract like this. Fair enough?